This tutorial is 1.6 about measuring angles. First thing that we have to know is that there's this particular notation for writing angles, which looks just like an angle like this. Now, I actually prefer to put an arc mark through it. That's called an arc mark. And you'll see why later on throughout the year. But it's just, it's a little bit more universal, so I would prefer you to use this. So take a look at the bottom here, this example. When we have this angle EML. Whenever we name an angle, it's the vertex angle that is always written in the middle. So the corner of an angle is called the vertex angle. And that is always written in the middle. So for example, I'm going to name this angle. So I'm going to write my angle notation. And just make sure that you're going in a consistent manner. So either go clockwise or counterclockwise. For example, if I start here with E, okay, I'm going to write angle E, and then I have to write the vertex angle always and every single time. So M would go next, and then the last point, L. And of course, these are my initials. Another way you could do this is by going the other direction. So I could also say that this is angle L, M, E. And it doesn't matter. The only part of this that matters is that you're going in a particular order and that the vertex angle is in the center. So let's take a look at a few different kinds of angles. Okay, so the 4 different kinds that we're going to take a look at right now are acute, right, obtuse, and straight angles. In order for an angle to be considered acute, it needs to be between 0 and 90 degrees, not equal to 90 degrees. Notice that these inequality signs are the way that they are for a reason. This angle cannot be equal to 0 nor equal to 90. It just has to be something in between. So that's where that degree measure is. In order to be a right angle, X has to be exactly 90 degrees. And right angles have a special notation for their angles in which it is a box. So if you look in the picture, it's not a curve like the other pictures. It's a little box. And then we have obtuse angles, which have to be greater than 90 degrees, but less than 180. Once again, it can't be equal to either of those, just in between. And then the last one that we have is called a straight angle. And this is kind of like a right angle in that it has to be exactly equal to a degree measure. In this case, 180 degrees. Okay, so then what does it mean for angles to be congruent? Hopefully you've heard this word before. In this particular case, it means that they are angles with the same exact measure. So the way that we do our notation here is, let's say I've got an angle here and an angle here, and they are congruent. I'm going to name this one angle 1 and this one angle 2. So if the measures of their angles, so 80 degrees, 70 degrees, something specific, then I would write in the notation like this. I first of all need my angle notation, so angle 1, but in front of it I'm going to put an M, and this M stands for measure. In other words, I'm talking about a specific number value here. Okay, so this would be the measure of angle 2. Now, congruency does not have anything to do with a number. It has to do with the characteristics of the figure. So these two figures, because their measures are the same, then the two figures are congruent. And the way that we use that, or write that out, is I'm going to say that angle 1 is congruent, and congruent is written like an equal sign with a squiggle on top, is congruent to angle 2. So this up here, where there's an M, this means that it is standing for a specific measurement, whereas this is telling you that you're talking about two figures. All right, now we're going to take a look at a couple more things, and then we'll be done. So the next thing that we're going to look at is what's called the angle addition postulate. And we're going to abbreviate that by AAP. We're going to run into a lot of theorems and postulates along the way, and it's just nicer to abbreviate them instead of writing them out over and over again. So AAP is angle addition postulate. And all it says is, this example down here is going to show you that the sum of the two angles inside, these two smaller angles that are in red, so this angle here and this angle here, should add up to give me the entire length of the full angle, this whole thing. So when we look at this problem, it says, what is the measure of angle SVT? So I'm going to highlight that in red, SVT. If the measure of RVS is equal to 50 degrees. So let's go ahead and find that angle. So angle RVS is right here. So this is 50 degrees. And then it says, and the measure of angle RVT is 125 degrees. So this whole entire thing is 125 degrees. So just by looking at this picture, if I'm trying to find this missing angle, which I'll just call X, I know for a fact that that 50 degrees, when I add that to X, it should add up to give me the entire measure, which is 125 degrees. So what do I have to add to 50 to get 125 degrees? It should be 75 degrees. So that's the angle addition postulate. All right, we're about to look at the last thing. Okay. So here we have 4 different kinds of angles as well. So the first one that we're going to look at is called vertical angles. And vertical angles, in this particular picture, we see 2 lines intersecting each other. It just so happens that if you have this case, then look at the positions of angle 1 and 2 in black. You see how they're one on top of another? They're pretty much mirror images. They will always be congruent. And that's really important for us to know. So I'm going to just write down here that angle 1, notice I'm not putting the arc mark this time, which is okay, is congruent to angle 2. So as long as they're vertical angles, then they're congruent. And so now if I look at the blue angles 3 and 4, since they are also directly across from each other, they're like mirror images, they are also going to be congruent. And if you don't get it right away, it's okay. You will very quickly, because this is not going to go away anytime soon. The next one is called adjacent angles. And all adjacent angles mean is that, and I'm going to do this in orange, is that I've got 2 different angles that share an endpoint and a side with each other. So they're pretty much just have to be right next to each other, but very specifically they have to have an endpoint, you can abbreviate that, and a side in common. And if they don't, they're not adjacent. The next kind are complementary and supplementary, and you should already be familiar with these from your earlier years in math. Complementary angles are angles that add up to 90 degrees. So in this case, I've got angle 1 and angle 2 here with a right angle, and I know it's a right angle because of the box. So I'm going to say that the measure of angle 1 plus the measure of angle 2 should equal 90 degrees. And then with supplementary, it's just the opposite. Instead of it adding up to 90 degrees, it should add up to 180. So I'm going to go ahead and write that out here. And one of my students showed me that there's an easy way to remember complementary and supplementary. So watch what I do with the first letters. Look at the word complementary and look at the capital C. If I drop a line straight down, then it looks like it's a 9, and then the O next to it is like 90 degrees. So that's one way to remember it. You don't have to remember it that way, but that's one way. And then if you look at the word supplementary, what should I do here? I'm going to put a 1 in front of the S, cross the S like this, so now it looks like an 8, and then make this a 0. So that's 180 degrees. And if you don't think that this is helpful, then you don't have to use it. So that is section 1.6.